Okay, hi guys. So here, AP Calc Big Quiz B practice video. It's a quest. Okay, Big Quiz should be a quest. Yeah, I forgot. Okay, so I'm just gonna do 5 limits, and because we did the intermediate value theorem in class today, and you should be able to just look through your notes or look at videos 1-11 and 1-12. No, really just 1-11. And the problems we did in class, that should be enough. Okay, so we're doing this limit. So basically, guys, your first 5 problems, they're not going to be necessarily in this order, but you're going to have, okay, so if we look at this, problems like 1 through 5. So the top row are very similar, the second row are very similar. So each row has very similar problems. And so number 1 is not necessarily going to be like this, but one of the 5 problems will be like this. Same with number 2. The number 2 I do won't necessarily be like this, but one of the 5 problems will. Number 3 won't necessarily be like this, but one of the 5 problems will. So, okay, hopefully that's clear. So it actually won't be in this order at all. Okay, so you ask yourself when you're doing the limit, is it going to infinity? The answer is yes. Then you look at the input. Do you see a polynomial over a polynomial anywhere in the input? Yes. So we're going to use the end behavior model. So I'm just taking these highest power terms. Okay, and then, so I'm going to have 3x to the 4th over x squared. Okay, and you cannot drop the limit until the x's go away or until you do the substitution. So this is 3x to the 4th. No, to the 2nd. All right, and then, so at this point, I am dropping the limit because in place of x, I'm putting an infinity. So at this point, I'm substituting. Infinity squared is infinity. 3 times infinity squared, that's infinity. So the answer to this one is infinity. All right? Okay, so the 2 rules for dropping the limit are you could drop it when there's no more x's, and you could also drop it when you direct substitute. And those things will usually coincide with each other. Okay, now this one. So you ask yourself, is the limit going to infinity? Yes. Is there a polynomial over a polynomial involved? Yes, right up here in the exponent. So I could use the end behavior model up here. However, I just have a single term over a single term, so really there's no need to even use the end behavior model. Okay, so I can go right ahead and plug the infinity in. So this is equal to e to the 2 over 3 times infinity. Okay, but this is equal to e to the 2 over infinity. 2 over infinity, guys, that's just 0. So this is e to the 0. This is 1. All right, and there's no need to show all of these steps. Like if you just, you could even go right from here to e to the 0 and then to 1. All right, that would be totally fine. Okay, so there's that. Now the third one. Is the limit going to infinity? No. So what you've got to do, if the limit's not going to infinity, you just try direct substitution. So when I plug 4 into the denominator, do I end up getting 0? No. So I can just direct substitute. So since I'm not going to have any more x's when I direct substitute, the limit goes away. And then this is 16 plus 4 over 2. That's 20 over 2. That's 10. Okay. The fourth one. Is the limit going to infinity? No. So you try to direct substitute. But when you do, plug -1 in for this x, you get 0 in the denominator. So this is where you go equals the limit as x approaches -1 and leave yourself a blank. And then off to the side, you take the input and you try to factor it. So this is x squared minus 1 over x plus 1. This is x. Okay, and those x plus 1's cancel, and that's what I wanted to happen because this x plus 1, that's what was preventing us from direct substituting. So if whatever prevented you from direct substituting cancels, then you could go back up into the limit and then direct substitute. That's negative 1 times negative 2. That's just 2. Okay, that's the fourth one. The fifth one. Okay, is the limit going to infinity? No. So you try to direct substitute, but we get a 0 in the denominator. So I go equals the limit as x approaches 5 with a blank. And then off to the side, I do this thing. So I've got 1 over x. And I'm going to put that over 1 because I'm going to have to use keep, change, flip eventually anyway. So, alrighty. So what is my common denominator is going to be 7 times x plus 2. Okay. So I want this denominator, so I'm missing a factor of 7 in this denominator. So I multiply by 7. So this 7 comes over, minus. And then in this denominator, I'm missing a factor of x plus 2. So I multiply both the numerator and denominator by x plus 2. Okay, this is equal to. So I end up, so this up here, this is 7 minus x minus 2. All right, so that ends up being 5 minus x over 7. Okay, and then keep, change, flip. So I'll go down here. So change. Okay. Alrighty, and then I'm gonna keep going. Okay, and guys, you should remember from last year, these don't cancel to make 1 and 1. They cancel to make negative 1 and 1. So now that this was the factor that was preventing me from direct substituting, now that it's gone, I can direct substitute. So I got to go back up into the limit. Okay. And now I direct substitute, so the limit can go away. 7 times, so 5 goes in there, negative 1 over 49. Okay, now I'm not doing the intermediate value theorem part of your practice stuff, because we did that. I think we did enough of that in class, guys, and you have your videos you can go back and watch, and okay, but you can email me if you have any questions. Okay, so scody@svsabers.org. Okay, email me or come see me tomorrow during the day. You could pop in any time. And, okay, as long as you're prepared, guys, you're going to be great. Okay, I'll talk to you later. Bye-bye.